In this section, we are going to learn about array. We already learned from the second week. We learn about list, we learn about tuple, we learn about dictionary, we learn about set. So for the sequence classes, Python has the built-in types like list, tuple, string, and each of these sequence types support indexing. They put the index to access the individual element of a sequence. For example, you can use the A square I. This is to check where is the index or where is the position of that particular element. Okay. So each of these types use an array to represent the sequence. So for example, if it is an array, then it is a set of memory location that can be addressed using consecutive index, or you have the consecutive indices. You can see this is index 0, this is index 1, this is index 2, and so on. And suppose this is index I, this is n, the number of array that you have. This is only just for the refresh about the materials about list and tuple. When you use the list and tuple, it is ordered. So you have the sequence from the index 0, 1, 2, 3, and so on. The same as the string. String is a kind of ordered characters. Let's say I have hello. Then we say this is index 0, index 1, index 2, index 3, index 4. A list it is a sequence of mutable objects, okay, numbers and strings. Tuple it is a sequence of non-modifiable or immutable objects. Okay, we already learned. If it is a list, you can change, you can modify. If it is tuple, you cannot modify the element. And if it is a string, it is a sequence of character and it is also immutable. It is non-modifiable. However, you can also see the other kind of classes like set and dictionary. So set and dictionary, those are unordered. Unordered means there is no sequence or there is no order. When you put a set of your data, then it is non-redundant a group of objects. The order is not guaranteed. And if it is using the dictionary, so it is a pair of key value objects. So you have key to represent what is the value of that object. Yeah, this is just for the revisit. Okay, you already know about the list. If it is a list, then you can specify with the square bracket. And the element on the list can be anything. It can be combined string, number, boolean. Or if you have a list with the same object, float, float, and float, then you can use the list. If it is a string, so you have name equals to computer. So you can check what is the index 0. The index 0 means this is the character C. Then you can get A is C because it is in the index 0. If it is a tuple, so the data is the same with list, but you're using the parentheses and the data is non-modifiable, so you cannot change, you cannot modify the element. Even though they are the same data, but you cannot change the element, like not the same as the list. If you are using the set, you can use the curly braces. So the curly braces refers to the set. And if you have double data like this one or redundant data, then one of them will be removed. So the num will be only the unique data or non-redundant data. If we look at the array, okay, so the array is something like an object in every single memory address like this one. We call this is a single memory address. An array can store the primitive elements. Okay. Primitive elements. What is primitive elements? We call it primitive elements because we can save a character. A character means A, B, C, D, something. Or we can save integer. Or we can save float. Or we can save Boolean. So those are the primitive elements. And we call this is a compact array. So whenever we call the data, let's say this is the data with the variable A, I can check the A index 0. Then directly I can get the result is S. But an array can be a reference to object. So an array can also store references to an object. For example, in the index 0, I'm going to put a name, green. On the index 1, I have a person named Joseph. In the index 2, I have a name Janet, and so on. So you already learned also in the OOP, object-oriented programming. We can save in index 0, it is the person 1. In index 1, this is the person 2, and so on. So if it is the person 1, so we can check the person 1 dot name. So I want to get the name of the person 1. Maybe this is the P2. So I want to get the name of the person 2. Then I will get Joseph. Okay. Because this is the reference to an object. It is not a simple data, not a simple element, or not a primitive element, but it is more about objects. Now, when we are dealing with the compact array, so the compact array means there is a kind of module. So the array module provides the array class for efficient storage of primitive data type arrays. If you are just using the primitive data type, like what I mentioned to you, character or integer, float. So you just use the array because it is more efficient compared to the list. It is the primary support for the compact arrays. So we have the array module. We will take a look later. The array constructor needs a type code or a character as its first argument to specify the data type. For example, I want to have one variable, primes, and this primes is an array, and the data type is I. I means integer. Then all the data here should be integer. 2, 3, 5, 7, 11, 13, 17, 19. Those are integer values. If you put float number in one of the element, then it will be errors. Okay, so this is not the same as the list. This is just an array. In the array class, so there are several kind of type codes. Okay, yeah, there are several kind of type codes. So we have B. It is a signed character. Big P. It is unsigned character. So Char means character. You can have any kind of character. For example, symbol dollar, or you have the character less than or equal than or not equal. Yeah, this is the character. Unicode character. So Unicode character means, yeah, uni means single. Yeah. There can be another kind of character. For example, if you are using the Korean character, Hyok, Nyeon. This is one of type of the Unicode character. So you can check how many bytes that consume. So if it is a signed character, it is 1 byte. If it is Unicode character, it is 2 or 4 characters. Sorry, 2 or 4 bytes. The higher the number bytes, then it means the higher energy that you need to use. If you are just using a very small number, you can use the short integer because the number of bytes is 2. But if you are using I, the signed integer, the number of bytes will be about 2 or 4. So it is higher. If you are using a very big data, of course, you need to think about the efficiency. The lower of bytes, the better. Okay. So we need to check the type of codes that is good for your data. If you can see float, there are 2 kinds of float, F and D. So the float with F, yeah, the number of bytes is 4, and the number of bytes for float with the type D is 8. It means they are different in the range. This float has a smaller range than this float. Now we can take a look on the. I guess I put. Yeah, I put this Google Colab. Let's just go to the Google Colab. Yeah, you can see the Google Colab code. It is a list, common list. In the common list, you can define any kind of data in the list. Integer, float, string. So any data will be okay. If you are using a string, then you can split each of the character into the element. You can put the same string in the list. Okay. But now, if you are using array, how to use array? First, you need to import the array. There is an array class, and I need to define what kind of data that you are going to use. Let's say I'm going to use I. This is integer. Then all the data will be integer value. If I want to specify as a float, then you need to use D or F. Of course, as I mentioned to you, if it is D, then the number of bytes will be higher than F. If your data is not that huge, then just use F. But yeah, maybe for now, let's use D. Then this is the data that we use for float number. The other kind of way to access the data is similar with this. For example, I have the array A, and then this is an integer with the value 2, 4, 6, and 8. So I want to know what is the element index 0. Then 2. What is the element of index 1? It is 4. What is the element of index minus 1? It is 8. So it's the same. If it is an array with the list, let's say I'm going to make a list, and I know that those lists contain only integer number. So I can put those into the array, and I can specify that those elements are integers, and I can put it into here. So people say that using this array, it is more efficient compared to using the list when you have a big data. And slicing is the same with the list. For example, I want to check the data from the index 2 until 5, or 5 minus 1. Or if I want to check the index until minus 5, or I want to check from the index 5 until 10. I want to check all the data. You can have this one. The result will be like this one. So they specify whether this is I or D or other things. Because you already specify this is I or integers, then they will always show I in this case. This is a part of list, so you can modify. You can modify the element. For example, I want to change, I have the value 1, 2, 3, 5, 7, and 10. For the index 0, I'm going to change into the value 0. For the element 2 until 5, I want to change to 4, 6, and 8. Then the index 0 now becomes 0. The index 2, 3, and 4, the index 2, 3, and 4 now becomes 4, 6, 8. So this is the same with the list. You can also apply the append and extend. Okay, last time we learned in the list, okay, we have append. If it is append, then we want to just add one element. If we extend, it means we want to add more than one element, or we want to append with another array. So we have 1, 2, 3, 4, and then we have 1, 2, 3, 4, 5, 6, 7, because we extend with an array, 5, 6, 7. If we want to delete or if we want to remove, okay, this is to remove one number. It means I'm going to remove the third element, 0, 1, 2, the index 2. After I remove it, then the remaining value will be 1, 2, 3, 4. If I delete number, it means I delete all the numbers. So deleting the entire array. When you delete the number, then of course you cannot find the values, or you cannot find the variables. That's why it is error. Name number is not defined. Okay. Yeah, in the application, you can do a lot of things. If you are using the list, it will be more applicable to the industrial domain. But if you are using only array, maybe it is only a part of the data that you have. For example, now I have the inventory data. So the inventory data, I have the smartwatch, I have the headphones, I have the portable charger, I have the Bluetooth speaker. Okay. And let's say, yeah, this is the number of inventory that I have. Okay. So the product ID is the index 0, the name is index 1, and the quantity is index 2, and the price is index 3. So this is the name, this is product ID, this is the quantity, and this is the price. Maybe the price is in dollar. Okay. Then you can check. So you already have the ideas how to deal with the list, how to deal with the condition and repetition. So for example, I want to check the low stock items. Right. Oh, sorry, I need to put the. So for example, the low stock items. What is the meaning by low stock item? Yeah, in this case, I want to know if the item quantity it is less than 10. Then this is the low stock item. I want to calculate the total inventory values. The total inventory values means the quantity multiplied by the price. And then I want to check for all items. I want to apply discount to some of the item. So you can apply some discount, let's say, because if the price is already higher than 120, let's give 10% discount. Then let's set up the price threshold and let's put the discount percentage. If the price is higher than the price threshold, then let's give the discounted price. The discounted price will be the item price multiplied by 1 minus the discounted percent, and so on. Yeah. Let's say I have a new item. So I want to sell a new item, which is USB-C cable. So now I buy 50 items and each of the item with the price $15. So I can use a pen in order to put this item into my inventory. And yeah, I have other new products. For example, I have the USB 3 cable, I have the HDMI cable, I have HDMI cable, and then I want to put those into the inventory. So you can use extend. So now you can see the difference between append and extend. Yeah, those kind of things are one of the application. So when you do with your team project, you can do something like this one as well. Yeah, those things are explained here. I think yeah, you can check the details. Now, the array has the operation. First, it is about insertion. Let insert object O in the index I. So I want to insert in the index I and the object O. So in an operation at I comma O, we need to make a room for the new element by shifting forward the n minus I element. So what does it mean? I have the index 0, 1, 2, and then let's suppose this is the index I, and then n is the number of data that we have. It means I will have the data from A, I, if I equals to 0, then it will be from I until a n minus 1. Okay, n is the number of data that we have. Now, let's suppose I want to make a new insertion into the index I. So index I is here. So I'm going to insert a value here. Then what happened to this array? This array should be shifted because I'm going to put a new element here. Then the element in this position should be shifted here. The element in this position should be shifted here. The element in this position should be shifted here. This element should be shifted here, and the element here should be shifted here. Then we have a new element until n index, and n will be shifted here. So in the worst case, when I equals to 0, when I equals to 0, then it will take O(n) time. So if you are going to put the object O here, then it means you will take n times to shift every of the object shifting by one position until n. How about if we want to remove? If we want to remove the index I, let's say now we are in this position. We have index I, we have an object O. So in an operation remove I, so we need to fill the whole left by the removed element by shifting backward. Backward means we cannot leave this one as the whole. We need to fill in by shifting the next element into this part. If we shift the next element to this part, then we need to shift the next element to this one. We need to shift the element to this one. We need to shift the element here. We need to shift the element here. And in the worst case, if we are removing the index 0, it means it will take ON time. If we remove the element at in the index I, of course, then we need to remove this one, we need to remove, and remove. Now, the new array will be like this one after we remove one element at the I index. In the implementation, okay, because this is a dynamic list, the space used by the data structure with the array, it is ON, because we always have n number of data in the array. When we try to do the indexing at the element of I, sorry, this is I, okay. I means the index I. Whenever you do the indexing at that element, so it will take O1. So it will always have one time. For example, I want to check what is the element at index 0. So this is one time. I want to check what is the element at index 5. So this is one time. Okay, this is only one time. But if I want to add or remove, it will give you n time. This is in the worst case. In an add operation, when the array is full, instead of throwing an exception, we can replace the array with a larger one. So if you look at this one, when you try to check the length of the array, what is the length of the array? The length of the array will be n. Length of the array means the number of elements in that array. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. But if I remove 1, after I remove, what is the length of the array? We have the new n. The new n will be the current n minus 1. Okay. What about if I do the addition, the insertion? The original, when I have the length a goes to n. After I do the insertion, after I insert a new number, then when I do the length a, now the n will be, after this n will be added by 1. Okay. So because this is the dynamic list, so instead of throwing an exception, we can replace the array with a larger one. So in the array, we have the data structure, which is ON. And when we do with the add or remove operation, we have the ON. Now, there's a kind of, we call it the growable array or growth strategy. The growable array means when we have an array, there should be a way to expand the array. There should be a way to add the array. So in an add or operation without an index, we could always add at the end. So if I have only 1, 2, 3, 4, let's see, 2 and 5, and then 1 and 4. So I want to put another new element at the end. Then it means I will add one more. If I have a new number, or if I have a new element, then I will add a new. When the array is full, we replace the array with a larger one. How large should the new array be? So there are two kinds of strategy. We call it the incremental strategy, and the other is doubling strategy. We call the incremental strategy. It will increase the size by a constant c. We call doubling strategy. We call the double the size. So if we have the incremental strategy, then we have only one. If we double the strategy, then it means we have, for example, we have 4 elements. Then maybe we have another additional 4 elements to make it double. So which one is more efficient? Incremental strategy or doubling strategy? So if we do with the addition operation, this is the algorithm. When the t equals to the length of the S, the A will be a new array of size n, and then we will do the repetition from 0 until the n minus 1. And for every single data on the S, it will be shifted or will be moved to the A index I. So later on, now the S, it will be the new sequence from the array A. And then N will be added by 1. And then S in minus 1 will be the new object, which is 4. So this is the step by step when you want to add a new object. So we need to check the strategy, whether it is incremental or doubling. So we need to compare the incremental strategy and the doubling strategy by analyzing the total time, or the Tn, needed to perform a series of n at O operation. We assume that we start with an empty stack represented by an array of size 1. And we call the amortized time of an add operation. It is the average time taken by an add over the series of operations. So the time that we have, it will be divided by the n, or how many data that we are going to add. Because this is the amortized time. And we start from the empty stack with the array size of 1. So let's see. With the incremental strategy, we replace the array k equals to n divided by c. Okay, equals to n divided by c. So the total time of a series n add operation is proportional to like this one. Now suppose you have the n data. With one additional object, you will have c. With two additional objects, you will have 2c. With 3 additional objects, you have 3c, 4c, and so on. Okay. Then, yeah, if you know from the mathematics, this is a series. Okay. C plus 2c plus 3c plus 4c. Then we can put just a mathematical equation like this one. C multiplied by 1 plus 2 plus 3 plus 4 until plus k. So this kind of equation we can simplify into C k multiplied by k plus 1 divided by 2. Okay. Since C is a constant, okay, we know from the big O notation. What does it mean by constant? Just a number. Let's say if it is 10K, so it is a constant. So we can drop the constant is on the big O notation roots. Because C is a constant, then the Tn becomes On plus K divided K power of 2. And N plus K power of 2. So the operation will be N plus K power of 2 because of this formula. Then the amortized time is the Tn divided by N. It means the O N plus K power of 2. Let's suppose K, yeah, we can just put K that's maybe similar to the N. Then we have O N plus N power of 2, or it is similar to the O N power of 2. So this is the worst case. If we have the O N power of 2, okay, we have O N power of 2, and we want to divide with N, then the amortized time of the add operation will be O N. The overall operation is O N power of 2, but the amortized time is O N. How about the doubling strategy? In the doubling strategy, we want to replace the K equals to log raised to N. K is log raised to N. It means like this one. If I have the total time from the original array, which is N, now I have another series of add operation. If I add only 1, and then I add 2, and then I add 4, and then I add 8, and so on. So we want to double, 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 double. So whenever you have a new data, let's consider it a double size addition, double size addition, double size addition, double size addition. And if you do with the geometric series, this one can be simplified into this equation. 2 power of k plus 1 minus 1. Okay. Then, yeah, if you simplify this equation, it becomes 3n minus 1. The Tn, or the total operation, as you know, if this one is only this one, then this is 3n minus 1, then it becomes On. If it is On, the amortized time will be On divided by N. Then it will be O1. So using the doubling strategy, it will give you the amortized time O1, and the total operation will be On. Yeah, this is the implementation of this dynamic array. I give you the code in the this is from the book, the dynamic array. The capacity starts from 1, and then it makes the original array, and then the length will be the n, get item, and then whenever we append, so we use the double capacity. So the resize, it means we try to use double, because based on the experiment that we have on the mathematical basis, doubling strategy is more efficient. We just have the amortized time O1. Then we use the doubling strategy whenever we resize the array. Okay, so whenever we insert, also we will check if the n is equal to the capacity, then resize with the doubling strategy. The doubling strategy is more efficient than the incremental strategy. Okay, so you can see how to remove, how to insert, and how to make the new array. Okay, so that's all. we learn about the recursive, we learn about the array and the growable array, and we saw some of the Python code. So next week, you will do quiz